Hello everyone. In today's session, we are going to discuss about various types of multi-stage amplifiers. So multi-stage CE amplifier and Darlington amplifiers. So let us start with multi-stage CE amplifier. So already we have discussed about CE amplifier. CE stands for Common Emitter Configuration. So there are three various types of configurations are available: common base, common emitter, and common collector configuration, in which the most useful configuration is common emitter configuration. Now here we can see this is multi-stage. So now here we can see this is multi-stage CE amplifier. In multi-stage CE amplifier, its characteristics are like this. Its voltage gain is greater than unity. Voltage gain is further increased by cascading. That means whenever we are going to connect more number of stages of CE amplifier, then you will increase the voltage gain of the system. The characteristics of CE amplifier are such that this configuration is very suitable for cascading in amplifier circuits. Hence, most of the amplifier circuits are used CE configuration. That's why commonly use CE configuration rather than CC and CB configuration. Now here in this diagram you can see this is the cascading CE amplifier. Now I am using this word cascading, so it means you are going to connect in series, so it means it is cascading. Now Vin, that is your input voltage, here it is going to the capacitor. This circuit is similar to the RC coupling amplifier. Now multi-stage CE amplifier, in which you can see we are going to use two different stages. One transistor is Q1 and another one is Q2. Now you can analyze this circuit diagram with DC and AC analysis. Whenever you are DC analysis, at this time your capacitor will be removed, so that there will be a DC analysis. Because here we are using capacitor, so capacitor block DC and it allows AC signal. Now we are using here bypass capacitor, that means it increase your voltage gain from this system. So this is basically multi-stage CE amplifier. Now next one is the most important, Darlington amplifier. So Darlington amplifier, it is founded by the Sidney Darlington in 1953. That's why its name is Darlington amplifier. This amplifier, it is commonly made from CC configuration. CC configuration stands for, it is common configuration, common collector configuration. Now here you can see in this circuit diagram, basically we are going to use two different types of transistors. Number one, it is Q1, and number two one, Q2. You are applying input from the base terminal and you will get the output from the emitter terminal. That's why it is known as emitter follower. So basically this is common collector configuration. Its another name is emitter follower. It is also used as a switch. Now here you are using as an amplifier. So basically we are using three different types of terminals. At C, collector terminal plus VCC is connected. We are going to apply input at the base terminal and we will get output from the emitter terminal. Now whenever you are doing DC analysis, at this time your capacitor will be removed. So you just have to apply KVL. From that particular equation you will get the equation. Now whenever you are doing AC analysis, so you have two different type of AC analysis. Another one is pi and T model. So in this, here you can see we will get beta 1 and beta 2. This is your gain. We are applying IB1 as a input current. Then we will get IB2, which is our output of Q1. But this is also input for the Q2. That's why it is known as IE1. And at the end, we will get output IE2 across this RE, which is known as emitter resistance. Now, here we are also using capacitor. So, capacitor allows the AC current and it blocks the DC current. So, this is emitter follower circuit, which was just discussed legs to meet the requirements of the circuit current gain AI and the input impedance ZI. Now, in order to achieve some increase in the overall values of circuit current gain and input impedance, two transistors are connected as shown in figure. Now, let us discuss about characteristics for the Darlington amplifier. So basically, it has extremely high input impedance, which will be in mega ohm, right? So another point is extremely high current gain. It is in several thousands. Extremely low output impedance, which is in few ohm. Now this circuit is known as common collector. That's why it is known as voltage buffer. Now what is voltage buffer? Voltage buffer, that means whenever you are providing cascading, so first stage gain is 1. Now another stage also 1. So 1 into 1 multiply 1. So that means whenever you are providing 5 volt at the input side, you will get 5 volt at the output side due to this unity voltage gain. So that's why here we are not using for the voltage gain. This is current gain. This is basically current amplifier. So whenever you need current amplification, you just have to use Darlington amplifier. So basically CC configuration, or we can say emitter follower. Now whenever you need voltage gain, at this time you have to use CE configuration, which we discussed already, multi-stage CE amplifier. Since the characteristics of Darlington amplifier are basically the same as those emitter follower, the two circuits are used for similar applications. So basically this is the same as we discussed about emitter follower, or we can say common collector. So I hope you can understand about the Darlington amplifier and multi-stage CE amplifier. So that's it about today's lecture. Thank you.